In response to a current situation, our team has developed an integrated turbine blade inspection system, as you can see in the PowerPoint slide. And our system actually can be divided into 3 different parts. The first part, as you can see is here, the blade, right? We will design a fixture with the turntable. And then, so that it allows the blade to be fixed for scanning, and the turntable will allow it for the rotation. The second part is the 3D scanner. It captures the physical objects and then converts it into the virtual model in the computer. And the third part is the software part, as you can see on the right-hand side. And this part will try to analyze the scan data from the scanner and try to compare it with the original design specification for further inspection. And in the following slide, I will try to explain part by part to you. So here is the overview of our hardware in our system. Apart from the fixture and turntable, actually we got an Arduino, which is a control board. And it will receive the orders from the computer, and it will send a signal to the servo motor. And then the servo motor actually is connected to the turntable to allow it to have a rotation for 360 degrees. Also, we also have adapters, so that our 3D laser scanner can be integrated into our whole system. So here is a detailed design of turntable or fixture. So once you want to scan the blade into the computer, the first one is you have to put the blade into our central cavity of the fixture, as you can see. And then, as our fixture is designed for different sizes of the blade, for the blade with smaller size, you can just put in the central cavity, and by adjusting the screw at the side, the blade can be fixed at the one end, so that we can achieve the fixation for different sizes of the blade. So after you have put the blade onto the fixture, you have put the whole set onto our designed turntable. The turntable composed of many parts, but mainly the servo motors and also the ball bearing. So once the Arduino board control board sends a signal to the servo motor will drive their whole system with the aid of ball bearing, and that turntable to be rotated for 360 degrees. So after your setup, we can begin our scanning. Here's come to our introduction of the system interface and control part. As you can see, by making use of Visual Basic, we have developed a specific user interface for our system. There is 3 buttons. The first one is the 3D scanning. So once you click it, the system will start to scan. And the second part is the model reconstruction, and followed by the 3D inspection. And we will explain it one by one in the following slide. So before scanning, we need some preparation. And we have to communicate with the system first. And the first one is that we have to tell the system which serial ports we are using actually. And then we have to calibrate the motor and make it back to the initial position. Also, we have to tell the computer that how many steps we want to take, or in other words, that how many captured image you want to take during the scanning. So after you have set everything, the scan can be begin by pressing the scan button. So when you press it, the scanner will start scanning. And after scan it, the turntable will turn the fixture to other positions. And then you just click the scan button again, and we begin scanning. And so on. It will repeat a few times until all the captured image is captured. So after the 3D scanning part, we go on to the other steps, which is the model reconstruction. So as all the scanner data has been transferred to the computer, it needs to be processed. So we have to filter the noise, and also try to draw the point data into plane. And we try to have some data alignment and registration. At last, we can just merge them and can construct the model like the right-hand side. Here's the model composed of different captured images from different angles. So after we have constructed the model, when it comes to the final part, which is the most important as well, for the 3D inspection. 3 kinds of reports or results can be generated by using our system. The first one is the CAV, Computer Aided Verification. So that you compare the scanned blade, how is difference in dimension with the original golden piece. And also you can compare by using the cross-section. And full detailed reports with detailed numeric data of each coordinate can be generated too. So now we would like to show you the video about how it really works in an overview. As you can see, here is our setup of our system. So at first, we should calibrate our system first. As you can see, this window is same as the PowerPoint slide I showed you before. We should choose the serial port, and then calibrate the motor and input the number of captures you want. So after we have calibrated the system, we can just start by putting the blade onto the fixture. And then we click the scan button. And the scanner, we try to scan the blade. As you can see, the red beam just passed through it. And then the scanner data, we transfer to the computer, and it will rotate to another position. And just scan, we will proceed to the next scanning. And the scanner will scan it again, and again, the scan data will transfer to the computer. And the turntable will return the fixture with another degree for another capture. And that is how our system generally works. So with now, we will pass to Huffy to talk about what is the further improvement for our project. Thank you.
Thank you, Ivan. So moving forward, the team has identified a few design improvement opportunities. Currently, our fixture can only hold one type of turbine blade. We hope to design or come up with a universal fixture, but it can hold all kinds of different blade sizes. The turnable table, angular position, as Ivan said, is currently controlled by a servo motor. To enhance the accuracy of the 3D